And this is the second problem of mechanical energy conservation or conservation laws. Right now I'm focusing on mechanical energy conservation, and this is only the second question. And you can see here on your screen that there is a round vertical cylinder of radius r fixed on a horizontal plane. Okay, an inextensible thread of length L is attached to the cylinder. You can see here, and cylinder side near the bottom. Initially the thread is tangent to the slide. Of course it must be a small block of negligible size, here it is, attached to the other end of the thread. The block is given an initial velocity v0 perpendicular to the thread. That's all right. So the block starts sliding on the plane, and remember the horizontal plane is smooth. The block is given an initial velocity v0 perpendicular to it, so the block starts sliding on the plane. How long will the block motion last, or how long will the block move if there is no friction? Oh, friction might be present. And how the motion will take place, there is an statement, and winding the thread around the cylinder. So first question is, how long will the block motion last if there is no friction? And second one is, how long will the block motion last if there is a friction between the puck? Oh, this thing, this is a small thing, and they are using a slang perhaps. Between the puck and the plane, the coefficient of friction is mu. Okay, we are going to solve it. First by using mechanical energy conservation, and second case we will not be able to use the mechanical energy conservation. I mean, we can see what can we use instead, but I have to make some adjustment before I'm going to solve this problem in particular. Suppose this was the thread winding the cylinder, winding around the cylinder. So इस तरह से thread घूम करके cylinder को wind कर रहा था. So suppose the thread has turned by a small angle phi. ये thread यहाँ था शुरू में, अब ये कुछ यहाँ आ गया है. मान लेता हूँ thread यहीं से शुरू होगा ना, वो तो thread कुछ wound होकर के कुछ यहाँ पहुँच गया, और किसी टाइम इंटरवल dt में ये थ्रेड थोड़ा आगे भी पहुंचेगा, और इस तरीके से ये दोनों कुछ एंगल d phi बनाता है यहाँ पर. मतलब I just assume that the thread has turned by a small angle d phi. So यहाँ पर इन दोनों जगह पर जो रेडियस होंगे, ये दोनों भी आपस में जो एंगल बनाएंगे, ये दिख नहीं रहा अच्छा, बट दिस एंगल विल ऑल्सो गोइंग टू बी इक्वल टू d phi, क्योंकि उनके टेंजेंट्स अगर डी फाई एंगल बना रहे हैं. इस लेंथ को मैं ds लिख दूं, तो यहाँ पर जो मैं छोटा सा डिस्टेंस लिया है मैंने, इसको dl लिखूंगा. बोथ विल बी डिफरेंट बिकॉज दोनों के रेडियस डिफरेंट है, और टाइम इंटरवल है, तो इसमें मैं सिंपल ही लूँगा, और या फिर dl. What is this dl? dl ये लेंथ है, that means मैं इस लेंथ को l ले रहा हूँ. इसका मतलब, इसको dl मानने का मतलब मैं इस लेंथ को l मान रहा हूँ, क्योंकि ये लेंथ dl है, तो l में थोड़ा सा और चेंज हो गया तो मैंने dl मान लिया. तो इसको dl मानने का मतलब एक मेरे दिमाग में आया कि मैं इस लेंथ को l कंसिडर कर रहा हूँ. वेल, दिस इज ऑल राइट, These are mathematical consideration. So इस लेंथ को मैंने ds बोला, इसको dl बोल दिया, तो ds can be simply written as l d phi, and dl length can be written as r d phi, दोनों में से डी फाई को मैं एलिमिनेट कर दूं अगर, तो डी फाई पहले वाले में आता है ds upon l, and second time it's get equal to dl upon r, so that I can relate ds and dl by ds equals ds upon l, ds equals l dl upon r, and something like that. I related both of them. Then the total length traveled by this small block thing, which was earlier called a puck, will be simply the total length. In this case is going to be s, that is integration of ds, and that will be l dl upon r, and the total length, the total length, the l is the variable of the integration, and I'm going to put the limit 0 to l. पहले 0 था, कोई भी लेंथ, सारा लेंथ ओपन था, और फाइनली पूरा का पूरा जब इस पर बॉन्ड हो गया, लपेटा गया, तो टोटल लेंथ लपेटा गया, और तो दैट इट्स गोइंग टू बी एल स्क्वायर बाई 2 मल्टीप्लाइड बाई आर, दिस रिजल्ट. सो I got the total length L, and time, since there is no friction, time we need to find out. Since there is no friction, so kinetic energy of this puck thing is going to remain constant, and that means the velocity, not exactly velocity, speed remains constant. So the required time is nothing but if the speed remains constant, the time you need will be simply distance traveled by this puck thing divided by its speed, that is going to be L square by 2 RB naught, and that's a simple, that was the most simple calculation. But what if there is friction present? तो फ्रिक्शन प्रेजेंट है, तो पक को एक टेंजेंशियल एक्सेलरेशन तो होना चाहिए. इट्स स्पीड गेट्स डिक्रीजेज, okay, speed decreases, that means what? Speed decreases, that means it will have tangential acceleration, I know. And this tangential acceleration provided by the kinetic friction, and kinetic friction provides the acceleration that is equal to deceleration, that is acceleration equal to minus mu g, because the motion takes place in horizontal plane. So acceleration provided by the force of kinetic friction will be simply minus mu g, so its speed gets decreased. And this speed is decreasing at a constant rate, so the total distance this free puck is likely to travel, the total distance, suppose that I don't call it S1, I don't know, so I'm going to call it S1. So total distance traveled by this small puck will be defined by v square equals u square plus 2s, and v becomes 0, and s, I would like to write it s1. S1 becomes v naught square by mu g. V naught was initial speed. So why this s1 not s? Because I don't know the puck reaches to the cylinder or not. So here are two possibilities. In the first case, if s is greater than equal to s1, that means the puck either does not reach the cylinder or just touches it, equal to just touches it, or the puck does not reach the cylinder. S, the total length s in the absence of friction is traveled, is greater than s1 this time. And that means s is greater than s1, that means s, we have written something like s equals l square upon 2r, and this is greater than s1, that is v naught square by mu g. So you can write here that v naught is less than equal to l under root mu g upon 2r. So this, in this case, what will be the travel time, total time इतने इसने कितना travel किया. तो इससे speed becomes 0 and action v equals u plus at. I'm going to use v equals u plus at, and in this case, in this first case, the time taken by the puck will be v equals u plus at, v naught by mu z. Yeah, and I got this time in this first case. And second case I would like to take like this. If s is less than equal to s1, that means the puck travels the distances and either collides with the cylinder or just touches it. इस केस में total travel time, how can I calculate? I simply know the total distance traveled, that is L square upon 2r. So I would like to go with s equals half at square, ut plus half at square. U was there, so s equals, using s equals ut plus half at square. A is minus mu z, and I simply write that s L square upon 2r equals v naught t minus a is minus mu z by 2 into t square. And so I get a quadratic equation in terms of time. And what is it? Eliminate. No, I can write like this, these things, that t square minus 2 v naught by mu z t plus L square by mu z r. And this is the quadratic equation. और इस क्वाड्रेटिक इक्वेशन के दो जो वैल्यूज होंगे वो हम लोग फाइंड आउट कर सकते हैं. एंड फाइंड आउट करने के बाद में एक चीज़ का ध्यान रखेंगे. इस केस में जो टाइम आएगा उस टाइम को मैं टी बी लिखने वाला हूँ, और टी बी मस्ट बी लेस देन टी है. सो what is it? The value of t is what? V naught upon mu z. Yeah, I can write it plus minus under root v naught square upon mu z square. That means it will become v naught upon mu z square minus L square by mu z r. So we got the value for t, and t should be less than this. In this case tb I haven't obtained yet. tb should be less than ta, and ta was what? b naught by mu z. That means we should select the minus sign here and plus sign should be omitted. And so tb, in this second case, tb can be written as v naught upon mu z minus under root v naught by mu z square minus L square upon mu z r. And like this you can do it. And to check the answer, if s is going to be equal to s1, then ta should be equal to tb. You can perform checking, and the problem is solved. Thank you for watching.